Over years of investigation and scientific discovery, humans have uncovered a great deal of information regarding space. Nevertheless, there is still a great deal that is unknown. Over the course of history, the insatiable curiosities and aspirations of our species have helped us make significant strides in our search for new celestial discoveries. The Voyager program is an example of one of these ongoing efforts. Voyager 1 and Voyager 2 are two spacecraft that were sent into orbit in the late 1970s, with the purpose of gathering information about our planetary system. In spite of all the technological advancements that have been made, there are still a great deal of mysteries surrounding space, which we have not been able to solve. Because we continue to get enormous amounts of data, which are difficult for us to comprehend, some people would argue that technology alone has served to make the concept of space more perplexing. The study of space may be quite challenging, especially when one considers the potential that there is life elsewhere in the universe. It's easy to understand why this is the case once one considers this possibility. Stay with us to the end of the video. There's a lot of information to be revealed. Even though these missions were never intended to last this long, they've given us some of the most important and groundbreaking information about the true state of our universe. As you may be aware, the twin Voyager missions have already been exploring space for the past 45 years, uncovering some of the greatest mysteries of our planetary system. The first of the two spacecraft, known as Voyager 1, was sent into orbit by NASA on September 5, 1977. Its primary purpose was to investigate Jupiter and Saturn, but it was also prepared to explore interstellar space. Only a few weeks later, on August 20, 1977, NASA launched Voyager 2, which had a mission that was quite similar to the mission of Voyager 1 spacecraft. Both of the spacecraft carried a variety of scientific instruments in order to collect data on the planets they traveled to. These devices included cameras, spectrometers, and magnetometers, amongst others. In the event that they came across intelligent life from another planet, they brought along a golden record with images and sounds from our planet, in the hopes of connecting with them. In 1989, after successfully completing its mission to research the planets beyond our solar system, Voyager 1 became the man-made object that is currently located the farthest from Earth. It is currently nearly 14 billion miles away. Voyager 2 has already traveled to Uranus and Neptune and is now voyaging towards the outside of the planetary system. The fact that Voyager 1 and 2 are still transmitting data to Earth more than 4 decades after they were launched into space is simply incredible. That's correct. Technology developed in the 70s is still the one responsible for transmitting information to us from outer space. How was that the Voyagers were able to do more than anticipated? In the 1970s, both Voyager 1 and Voyager 2 were put into space with the intention of making the journey to Neptune, which was expected to take around 30 years. But thanks to a groundbreaking discovery made by Michael Manevik, the spacecraft was able to slingshot further into the solar system and ride the velocity of planets. Voyager was able to get near Jupiter in just 12 years by utilizing the gravitational pull of planets and their velocity. Michael Manevik, a physicist from Soviet Union, came up with the innovative concept of gravity assist in 1961. This concept is also known as the slingshot effect, because of the notion it was possible for a spacecraft to make use of the gravity of a planet to modify their trajectory and accelerate to significantly higher speeds that would not have been conceivable using rocket propulsion alone. Imagine for a moment that a spaceship is traveling through space and is about to pass in front of a planet. As it does so, the spacecraft will take use of the planet's gravity in order to pick up speed and alter its course. Because of its similarities to a slingshot, this effect is also known as the slingshot effect. In the late 1970s, the use of gravity-assisted technology was critical to the accomplishment of successful launching of Voyager 1 and Voyager 2 spacecraft. The spacecraft was sent into space on a course that allowed them to go to Jupiter, Saturn, Uranus, and Neptune before ultimately departing the planetary system entirely. During the course of their missions, Voyager 1 and 2 took advantage of the gravity help offered by a number of planets in order to travel further and further into space. Without the aid of gravity assist technique, the Voyager wouldn't have been able to travel as far as it did, or make the groundbreaking discoveries that it did, including the first close-up image of outer planets and their moons. In addition, the Voyager would not have been able to make the discoveries that it did. Voyager 1 has had difficulties with its technology, despite the fact that it has made numerous groundbreaking discoveries. A decrease in the spacecraft's power supply was one of the most severe problems that arose. 3 radioisotope thermoelectric generators, or RTGs, transform the heat produced by the decay of radioactive isotope into electrical energy and is used to operate the Voyager 1 spacecraft. RTGs have a half-life of around 88 years, which indicates that their production will drop by approximately half after every 88 years. Because of this, the power supply on Voyager 1 has been decreasing at a rate of around 4 watts per year, which has resulted in a reduction of the spacecraft's capacity to transmit data back to Earth. But for the scientists, this was the least of their concerns. A transmission from Voyager 1 that was received not long ago has everyone in the scientific community on edge. The message was an indication that the spaceship had come across something from another world, or that there was something that had gone wrong with the spacecraft itself. Researchers were left scratching their heads as they attempted to piece together what had transpired when the transmission became garbled and distorted. After conducting additional research, it was determined that Voyager 1 had been the victim of a significant malfunction. It turned out that the problem was with one of its sensors. The plasma wave system was the source of the jumbled output. The breakdown of the plasma wave system was a source of concern because it's an essential instrument that is used to investigate the characteristics of solar wind. Because of the problem with the plasma wave equipment on Voyager 1, the spacecraft was unable to detect some types of plasma waves in the year 1980. To make matters even more difficult, Voyager 1 was already more than 14 billion miles distant from Earth at this point, making it extremely difficult to fix the issue remotely. Scientists have been putting in a tremendous amount of effort to determine what the problem is in an effort to diagnose it, but they're up against a big obstacle. The distance between the spaceship and Earth is now so great that it takes more than 21 hours for messages to travel between the two locations. But the team working on Voyager 1 was able to come up with a solution that allowed them to carry on making measurements using other sensors. In order to compensate for the loss of data caused by the plasma wave system, they make use of an instrument known as the Low Energy Charged Particle, or LECP, which was developed specifically to measure low energy particles. Because of this, they were able to carry on their investigation of the plasma environment around the spacecraft to locate the heliosphere's outermost edges. Also, the crew was able to discover the consequences of the problem by making use of the cosmic ray subsystem instrument. They discovered that the sensors were able to detect a slight raise in the quantity of high-energy cosmic rays. They believed that this rise was most likely brought on by a loss of data from the plasma wave system. Despite the fact that these alternative solutions proved to be effective, there was still a problem with the plasma wave system that needed to be addressed. The crew of the Voyager spacecraft continued to keep a careful eye on the ship, while also looking for potential solutions to the issue. They had made it a point to discuss their discoveries and collect feedback from other researchers working in the same area, so they might learn from the experiences and insights of their peers. In spite of this, experts are not giving up on the Voyager 1 spacecraft, because the issue of the plasma wave system has not been resolved to a significant degree. Over the course of its more than 44 years of operation, the spacecraft has collected data about the farthest regions of our planetary system that have been proven to be essential to humanity. The scientific community continues to harbor the belief that it will be possible for them to repair the plasma wave system while still advancing their understanding of the universe that surrounds us. The deteriorating state of the hardware aboard the Voyager 1 and the severe environment of space have both been sources of difficulty for the spacecraft. For instance, the cosmic ray equipment on board has undergone some degradation, which has resulted in the reduction of its sensitivity to high-energy particles. Voyager 1 is equipped with a number of scientific instruments, but one of the most vital is the cosmic ray instrument. It is intended to monitor the flow energy and direction of charged particles in space, including cosmic rays, which are high-energy particles which come from outside our solar system. Unfortunately, due to the fact that the instrument has been subjected to considerable degradation over the course of time, it is now significantly more difficult to provide precise results from measurements. The crew of the Voyager spacecraft has been toiling around the clock to come up with an innovative strategy for calibrating the instrument and making up for the sensor's gradual deterioration. They have also been engaged in creating new methods for interpreting the data collected by the device in order to make sure that it's as accurate as it possibly be. The deterioration of the cosmic ray instrument is, without a doubt, a difficulty, but not an unsurmountable one. The crew of the Voyager spacecraft remains resolute in their goal to keep breaking new ground with the findings of their investigation using the spacecraft. They are optimistic that they'll be able to discover ways to overcome whatever problems that may be present in them in the future. Also, the deterioration of the valves that control the flow of hydrazine fuel has caused some problems for the spacecraft's propulsion systems. This system employs small thrusters to orient the spacecraft and has run into some difficulties as a result. When one considers that the Voyager mission were launched more than 40 years ago, it's difficult to overstate how impressive the technological advancements made by those missions are. These spacecraft were able to go further and faster than they had ever been before, thanks to the slingshot effect and the gravity assist technique. Along that route, they made findings that paved the way for future advancements. Nonetheless, despite the amazing feats of engineering and inventiveness that are required for space exploration, these endeavors are never free of the perils and difficulties that can be encountered. Even the most complex and carefully conceived of systems are not immune to the possibility of experiencing sudden and unexpectedly severe issues. Thank you for watching. If you have any questions, let us know in the comments section. Also, at last, give a like to this video. See you soon.